Hello, I'm Dave Brown. Today, we continue our study of solid-state electronics with Chapter 4, which is entitled Transistor Amplifiers. I will describe the three basic types of transistor amplifiers, how they work, and their uses. The three circuit arrangements for transistor amplifiers are the common base, the common emitter, and the common collector. You will recall from our last session that the transistor consists of three layers of semiconductor material. A PNP transistor consists of a thin layer of N-type material sandwiched between two layers of P-type material. And an NPN transistor is made up of a thin layer of P-type material sandwiched between two layers of N-type material. These three different layers have names and are called the emitter, the base, and the collector. On a schematic diagram of a piece of electronic equipment, the transistor is represented by these symbols. The base of the transistor is represented by a straight line. The emitter is represented by an arrow, like this, or this. The arrowhead points in toward the base on a PNP transistor and points out away from the base on an NPN transistor. The collector is represented by a bent line, like this. Now we will put all these parts together and have a transistor symbol which looks like this. This is a PNP transistor. In a transistor circuit, we will apply the input signal between two of the transistor leads and take the output signal from two of the leads. Since the transistor has only three leads, one of the leads will have to be common. A common base amplifier looks like this. The input signal is applied between the emitter and the base. The output is from between the collector and the base. The base is common to both the input and the output, hence the name common base amplifier. This is a common emitter amplifier. The input signal is applied between the base and the emitter, and the output is taken between the collector and the emitter. The emitter is common to both the input and the output, hence the name common emitter. The third configuration is the common collector amplifier, and it looks like this. The input signal is applied between the base and the collector, and the output is taken from between the emitter and the collector. The collector is common to both the input and the output, hence the name common collector. The three circuit arrangements for transistor amplifiers are the common base, the common emitter, and the common collector. Now let's return to the common base amplifier and examine it in more detail. Remember, for a transistor to amplify, one P-in junction must be forward biased and the other P-in junction must be reverse biased. The proper bias of a transistor used as an amplifier has the base emitter junction forward biased and the base collector junction reverse biased. For a common base amplifier, we will use two batteries to provide the proper bias. For a PNP transistor, they will be connected like this, with the positive terminal of battery 1 connected to the emitter, which is P-type material, and the negative terminal connected to the base, which is N-type material. Thus, the emitter-base junction is forward biased. The negative terminal of battery 2 is connected through a resistor to the collector, which is P-type material, and the positive terminal is connected to the base, which is N-type material. Thus, the collector base junction is reverse biased. We have one junction forward biased and one junction reverse biased. If we were using an NPN transistor, which we can identify because the arrow is not pointing in, the polarity of the two batteries would be reversed, and the emitter-base junction would still be forward biased, and the collector-base junction would be reverse biased. Now let's define some more terms which we'll need to describe the operating characteristics of a transistor amplifier. Input resistance of an amplifier is the resistance of the input side of the amplifier. In other words, if we have an amplifier circuit like this, and we plug the input plug here into a phonograph pickup, the load that the amplifier circuit applies to the phonograph pickup will be the input resistance for the amplifier. The output resistance is the resistance of the output of the amplifier and gives some information as to what kind of a load can be connected to the output of the circuit. Gain is the ratio of the output signal to input signal, or the output signal divided by the input signal. In an amplifier, we have three kinds of gain. Voltage gain, denoted by AV, current gain, denoted by AI, and power gain, denoted by G. Power gain is usually expressed in decibels, or dB. We will now return to the common base amplifier and look at its characteristics. It has a low input resistance, usually from 25 ohms to 200 ohms, and a high output resistance, usually 300,000 ohms to 500,000 ohms. The voltage gain will typically be 500 to 1500, but the current gain will always be less than 1. The power gain will be 20 to 30 dB. The common base amplifier is limited to voltage amplification applications where the low input resistance and high output resistance can be tolerated. Now let's look at the common emitter amplifier. This is the most common and most used transistor amplifier. The common emitter amplifier can provide voltage gain, current gain, and power gain. In order to obtain amplification through a transistor, the base emitter junction must be forward biased, and the collector emitter junction reverse biased. It doesn't make any difference which side it's on or which direction it's pointing. The leg with the arrow is always the emitter. Again, we will use two batteries to illustrate proper bias of PNP common emitter amplifiers. Battery 1 in the base emitter circuit will be connected like this, with the negative terminal connected to the base, which is N-type material, and the positive terminal connected to the emitter, which is P-type material. Thus, the emitter-base junction is forward biased. To provide reverse bias for the collector-base junction, the negative terminal of battery 2 is connected to the collector, which is P-type material. Since the emitter-base junction is conducting when it is forward biased, the positive terminal of the battery is connected to the N-type base material through the forward biased emitter-base junction. The common emitter transistor amplifier circuits will look like this. If we were using an NPN transistor, the polarity of the batteries would be reversed. The common emitter amplifier is a versatile amplifier. Typical input resistance is 500 to 1500 ohms, and output resistance is 30,000 to 50,000 ohms. Voltage gain of 300 to 1,000, or sometimes even greater, is common, with current gain of 25 to 50. Power gain is usually from 25 to 40 dB. Common emitter amplifiers are used in radios, televisions, stereos, and in industrial instrumentation and control systems. The third configuration of the transistor amplifier is the common collector amplifier. The common collector amplifier is often called an emitter follower. As with the other two amplifiers, the base emitter junction must be forward biased. The forward bias is provided by connecting the positive terminal of battery 2 to the emitter, which is P-type material, and the negative terminal toward the base, which is N-type material. Battery 2 has a larger voltage than battery 1, and with the two batteries connected, the base, which is N-type material, will be negative with respect to the emitter. This P-type emitter-base junction will be forward biased. Let's look at what we just said with battery voltages applied. If we have 9 volts connected to the emitter and 6 volts connected to the base, then the base will be 3 volts below the emitter, or in other words, negative with respect to the emitter. The collector base junction is reverse biased by connecting the positive terminal to the base, which is N-type material, and connecting the negative terminal to the collector, which is P-type material. The common collector amplifier has an extremely high input resistance of over 100,000 ohms, and sometimes even mega ohms input resistance. The output resistance is low, usually 50 to 1,000 ohms. The voltage gain will always be less than 1, and typical current gains will be from 25 to 50, and power gains of 10 to 20 dB. This is a special purpose amplifier used mainly for resistance matching. An example would be to match the output resistance of a crystal phonograph pickup to the input of an audio amplifier or stereo system. It is used frequently in industrial electronics applications to match the resistance of measuring gauges to recording instruments. Let's summarize the characteristics of the 3 types of transistor amplifiers. Common base, the input resistance is low, the output resistance high, the voltage gain is high, the current gain less than 1, and the power gain 20 to 30 dB. For the common emitter, the input resistance is medium, the output resistance is medium, the voltage gain is high, the current gain is high, and the power gain is 25 to 40 dB. For the common collector type, the input resistance is extremely high, the output resistance low, the voltage gain less than 1, the current gain high, and the power gain 10 to 20 dB. Once again, here's the comparison of all 3 types. Remember, to function as an amplifier, the transistor must be properly biased. The base emitter junction must be forward biased, and the base collector junction must be reverse biased. For a PNP transistor, the base emitter junction is forward biased by connecting the positive terminal to the emitter, which is P-type material, and the negative terminal to the base, which is N-type material. The collector base junction is reverse biased by connecting the negative terminal to the collector, which is p-type material, and the positive terminal to the base, which is n-type material. For an NPN transistor, the emitter-base junction is forward biased by connecting the negative terminal to the emitter and the positive terminal to the base. The collector-base junction is reverse biased by connecting the positive terminal to the collector and the negative terminal to the base. For forward bias, positive to p-type material and negative to n-type material. For reverse bias, negative to p-type material and positive to n-type material. How do we know which transistor symbol represents a PNP transistor and which represents an NPN transistor? Just remember that for a PNP transistor, the emitter arrow is pointing in proudly. And for an NPN transistor, the emitter arrow is not pointing in. Today we have been considering the ordinary transistor, or junction transistor. In later programs, we will introduce you to some special types of semiconductors, such as field effect transistors